Okay, so hello everyone. I'll just start by introducing myself. My name is Helder. I work for Aris Group. I've been working there for 9 years now. I have a total of 14 years of experience in the software engineering field. So that's it for me. If you want to contact me after the conference, I put my LinkedIn below the slide, so feel free. So why this talk and what are we going to talk about? So in summary, we'll talk about AI. I plan on doing a very quick AI recap just for to refresh the concepts for people that may not be aware of them, but it will be very quick because I think today you heard enough of it. After that, I'll just talk a bit about what opportunities this brings for businesses, which constraints might prevent businesses from adopting it faster, and finally, we'll go over to Spring AI, which is kind of the key point of this presentation, where I want to show you how the Spring team put in place tools that will help mostly Java and Spring developers to get going quickly and to be able to more easily adopt AI in new, but also in already existing code bases. And for that, I will show you a demo. I will try to, well, I will speed my demo a bit because otherwise it will not fit in the time slot I have. But yeah, I might, if it gets too long, switch code and not code live, but we'll see how it goes. Okay, so AI recap. What is artificial intelligence? So there are a few definitions. AI is mainly the broad term of it. It designates systems that can perform tasks that typically would require human intelligence to do. ML is a subset of AI, so it's machine learning. It's algorithms that allow computers to learn from data, and they can improve themselves autonomously. Deep learning, once again, is another subset of ML, and it's a type of machine learning that uses neural networks to learn complex patterns from large amounts of data. And then we come to Gen AI, which is a very hot topic has been a very hot topic for the last years, and that's mainly what we understand under AI at the moment. And it's trained using neural networks, so we use deep learning to train them, and it's used for realistic content generation. So here you can see how they subset each other. Yeah, so Gen AI will be the main focus because that's what we will be implementing today. So we use it, as I said, for content generation. It might be text, image, video, audio. Today we'll mostly do text, but you can also generate other types depending on your software, other types of content. We use pre-trained models for that. So under those you have foundation models, which are the ones that you mainly know, as ChatGPT, Claude, etc., you name them. So those are very big models that have been trained on very large amounts of data and can thus answer to very different types of questions. You also have open source models, which typically are smaller because the idea is that you can also run those locally. Those are typically trained on a bit less data, but they are, less compute intense. Some small definitions that we are then seeing because those are typically the things that we'll implement in Spring AI. So prompt engineering is just a way of instructing the Gen AI models with natural or structured input. So it's how you talk to the model, basically. And you can, via prompting, also restrict and give the LLM boundaries. So you can tell it what you expect from the response that it gives you. RAG is a way of augmenting the knowledge of a large language model. The thing is, those models are pre-trained on lots of amounts of data, but that's very costly. And the knowledge that they have is limited to the time at which they were trained. And so they don't know about newer data, but they also, and luckily so, don't know about your private data because they have never seen that data. So you cannot ask them questions about that. It would be quite concerning if you could ask questions about your private data. And then you have also tooling and function calling. That's a way of helping LLMs to fetch fresher data. Okay, so I just want to quickly tackle opportunities for businesses. Okay, why bother with all of this? Why is it such a big topic at the moment? So it brings multiple opportunities. You can automate and accelerate internal operations by introducing smart automation in your operations, by producing smart tools, for example, by being able to query your existing documents instead of reading all the documents. You might have an assistant which you can feed your documents and then ask it questions. So it's you don't need to go through all of the text. You can just ask the model. You can use it for many things. So intelligent summarization, domain assistance. And something that's very, very nice also is you can introduce what's called self-service analytics, meaning that you can give independent access to non-technical people for them to interact with your data without having to request help from IT or data teams. You can also, depending on the types of business, transform your customer operations by introducing chatbots, which are there for you 24/7. You can put in place AI-driven support tickets. So those are just some examples of everything that you could do. And another thing is also you can empower your business and also gain have massive productivity gains by using AI. So typically a company that is using AI can really get a competitive edge, can accelerate its time to market. By putting in place your own tools, you can also ensure data sovereignty, meaning that instead of using public tools, you may produce your own tools. And thus, you can control where your data is going because today you don't always know. And you can also avoid what's called shadow AI. So I think everyone uses AIs at the moment in their day-to-day. The thing is, you don't really know how your employees or how your data is being used and where it's being sent, because people might just not be aware of the security issues it poses. So in putting in place your own tools, you can avoid your data being spread around because your employees would typically then use your own tools instead of just putting your data in ChatGPT. And yeah, so that's the opportunities. What is holding us back sometimes? It's mainly knowledge gap and skill gap because it has not always been as easy as it is today to implement such tools. So lots of questions arise: which tools to use? Do we need Python? So do we need to change our existing stack or our existing code base? Do we need to rewrite existing parts of the system to introduce AI functionality? And so that's where Spring AI comes in. So in classic Spring fashion, the Spring AI team put in place tools which allow mainly Java and Spring developers, of course, to easily integrate all those concepts that we've seen. They make it quite straightforward to do so without having to rewrite big parts of your code base. As you'll see during the demo, oftentimes really you can even reuse code that you already have and still use it in an AI augmented way. And yeah, so no Python required. In this case, it's extensible and flexible. It's modular, so everything that we know from Spring, and it's enterprise ready. So that's it. So I will go over to the demo. So for the demo, I prepared a small, let's say, tool that I developed. And we'll start, I'll just run it first. So we'll start by, 1 second, okay. Okay. So this is just an example tool for this demo, of course. It's not real data, it's not a real tool, or it's not a very complex tool. So the idea here is really to show you how you can start from something that you might already have in your business and augment it with AI functionality using Spring AI, and also to show you how easily the Spring team has made it. So we have, basically what we have is just an employee listing, okay? You can upload documents, you will see later why, but at the moment you can't do very much with it. So for the first part of this talk, I will put my code on the other screen because I think it's more interesting for you to see what I'm doing. So I'll start by, I will try to put the page on the other desktop so I can easily switch, and that way we can switch around easily. Just need to. Okay, so okay, so that's it. So let's start by adding. Let's start by just adding an interface to talk with our AI model. So for now, we can't type in anything. I prepared a small little component. Okay, I called this in advance because that's not really the topic of the presentation. And so now I just added a small box here, the chat assistant. And all this does is really take your input, send it to the backend, and then get the answer back and display it to you. Okay, so let's start by showing that for now it doesn't do anything. So I'll just say hello. And it replies, this feature is not yet implemented. Why? Because I kind of told it to do so. So I didn't implement anything. So as you can see, it's a basic response that gets returned. So now let's extend this and let's add AI to this. So first thing we need to do is we need, of course, a dependency. So I prepared this a bit in advance. So we'll start by adding the Spring AI dependency. Okay. So here I am actually using the Olama version of Spring AI. Why? Because I'm actually running this demo locally and the model is also running locally. Why am I showing you this? Because if you don't want to use this locally or if you don't want to use Olama, you can simply by switching the dependency target GPT or Claude, and Spring provides all of the mostly known, so it has support for all of the models that you know. So this is already one benefit because you can easily switch from local to public cloud LLM, and it will not take you lots of code rewriting to do so. So I added the dependency, and now we need to do a little bit of configuration. So this is the configuration we had before, okay? So here, the idea is to show that we have an existing code base and then we'll augment it. And so now all I need to configure for the moment is I need to configure Llama, so to tell where it's running. So place URL, because Llama might be running locally, but you can also put it on a server and let it run there. So if you don't have a powerful machine, you can do that way. And then I will tell it from all the models that I have running locally in Llama. I can show you. I just need to tell it which model I want to use. So in this case, I'll use Gamma 3 with 12 billion parameters. This is actually Gemini, but for local use. It's the open source model from Google. And then I'll go ahead and now add a configuration. And this configuration, I'll just declare my chat. So let's just annotate it so Spring finds it. And then all I'm going to do is declare one bean, okay, which is my chat service, chat client, sorry. And I'll need to inject a chat client builder. Okay. And now I'll just create a basic chat client. So a basic Spring chat client. And that's it. So now it's available for dependency injection. And let's add a simple service that uses this chat and that packages its responses. So chat service. Okay, I'll need some dependency injection, maybe some logging. Let's see. Okay, and in this service, I'll just add, so I'll just inject my chat client and I'll add one method which is response. Yeah, so this is a bean that I created in advance, just so it, okay, let's hide this. That's for after. So this is just the response that gets sent back to the front end. Then prompt, and here I'll request DTO. Okay. So basically this request is what is coming from the front end. And then I'll just return. I'll use the chat client. In the chat client, I will edit the message from the and then call and then content. Okay, so actually that's not really what I want to do. I want to put it in a variable first and then. Okay, so that's all it does. It calls the client. So this is a Spring AI chat client, which is now through the configuration connected with my local model. And so I just configure it. So I pass the message that's coming from the front end. I call it, and then I retrieve the content from the response. And this I just send back. And let's just now inject it in the controller, of course, because otherwise it won't work very well. If you okay, and now we'll replace this with our chat service prompt. That's it. Okay, let's run it. So load our notifications. So it's running correctly. And now let's try it again. So before I asked my chat assistant the question, it couldn't answer me. So now I'm just saying hello, just to validate that I'm really connected with the LLM. So now you see it's already taking longer because now it's passing it to the LLM, it's thinking, and now it replied back. So we have introduced intelligent chat into our application with a few lines of code. So just to recap, what did we do? We added one dependency. And as you'll see, this dependency will take us very far, very long. We added a very small configuration. Okay, if you inject the OpenAI dependency, of course, you would typically need to put in your API key, but the configuration is still very simple. And then I just declared a bean, which is a chat client, and used it in a fancy service just to package its response correctly for the front end and call it from the control. So that's the first part. Okay, let's keep this. Okay, so now we have a chat assistant. The thing is, it's not really limited. So we could use it, we could ask it basically anything. As I showed you, I said hello, it replied to me. You typically don't want to do this because people might then abuse your tool as a free ChatGPT because it doesn't have boundaries. So it will answer anything you ask it. So how can we now restrict it from replying to anything? So you can do that by via a system prompt. So you will instruct the chat on how it should answer. So how we can do that is by, when we build our chat client, we can add it a default system prompt, okay, which I will private. Okay, so it's basically just the same type of prompt you would pass to a ChatGPT, but you can define it here. And so you can tell it, you can instruct it to answer only questions regarding HR and employee related topics. It's a very simple prompt. Keep in mind, you don't want to use that simple prompts in production because they are not really limiting very much. So you need better prompt engineering, but this is just for demo purposes. Also, your results will vary depending on the models you use. That also has a big impact on how it performs. So that's another thing. So now I will reload this, and then we'll try to ask it again. So actually, I want to disable it first because, yeah, okay. So if I just forgot something, if the question is off topic, answer, you can also instruct it on how it should answer when a question is off topic. I cannot with that, okay. So bit more context. Okay, so it's running. So now I'll say hello. Tell me about Voxxed days. And it's telling me that it cannot assist with that because I set it some restrictions. Okay, so that's that. So that's all nice, but the thing is, our chat assistant is still not really connected to our application. For now, it's just an independent chat. You can still ask it, okay, HR-related questions, but it doesn't really know about your data. It doesn't really know about anything in relation to your system. So we want to change that. I'll start by. So how can we do that? To do so, we can. So I have my employee service, okay, that I prepared beforehand. It's really for demo. It's just a list, a map with some hard-coded employees. Of course, you typically would fetch those from a database or from some other API maybe. So how can we reuse that code and not need to put something special in place just for our AI, we can just come to our chat service, okay? Or we can go to our prompt, and now we'll just add something to the prompt. Oh, if asked, only ask questions. It's only answer 2 questions regarding the following employees. So that's one way of doing it, of augmenting your data. You can, by enhancing your prompt. The thing is, you don't want to do it always like that. This is one way, but you can imagine that if you have thousands of employees, your system prompt will quickly grow, which will not be good for LLM usage, because you would pay too many for tokens. It would take longer, and also LLMs have a limited context window. So I'm just showing this as example, but later we'll see another way of enhancing the context or the knowledge of the LLM by using RAG, which is a bit more advanced. But for now, this will do. So here I'm putting a placeholder, and then in our service, because we don't want to pre-configure, hard code the employees because they might change in the meantime. So what we want to do is we now just want to inject our employee service, which we already had, so no new code. And then we want to use it. So we'll just, okay, employee service, get all employees. I don't want to do that. Sometimes autocomplete does too much. Okay, so we'll just use one of the already existing methods from our already existing service, and then we can now instruct our client, no, not here. So we can now instruct our client to extend the system prompt, which we declared in the configuration. So system prompt, and we can add params, not params, but param, employees. So basically it's a map. So you pass it employees, it will replace this for you, and before calling the system prompt, and then it calls it, and then you get the content back. So now if I rerun this, it should answer questions. If I tell it if I ask it what does John Doe do? Crossing fingers because demo. Okay, so as you can see, it now answers questions, and it answered correctly. So it's identified John Doe from our employee list, and it returned us his job position. So works as an architect, a senior architect. So that's that. That's one way of augmenting your requests with data, with private data that the LLM knows nothing about beforehand. Okay. So now let's go a bit further. As you can see, we have been working this whole time with strings, okay? So the LLM responds a string, but the thing is we don't always want to use it like that, because here, for demo purposes, it's a chat, okay? But you might want to use what's called in Spring a chat client. You might want to use it internally in your code. So for example, you might have methods that do something and then just want to leverage AI before continuing in the code without even the users noticing it. And so for that, free text is not really reliable. So how can we now ask Spring to give us a consistent and reliable format, and maybe, if possible, give us the exact type of response that we need so that we can easily continue in our workflow without needing to map or parse the answer for the correct data. So Spring also thought of that, and for that we can use what's called structured output. How do you do that? So let's say I don't want now to be managing everything by hand, okay? Even in our chat client example, it can be useful to have a structured response. So let's drop the string. Let's say we now want it to return a chat response directly, okay? It doesn't like it because, okay, content is a string. So what can we do? Spring put in place the entity parameter, and here you just added the class. And what's happening here is that Spring will know about your class, and in classic Spring fashion will do stuff for you. So it will add context with your requests to instruct the LLM what format you want in the output. So you don't even need to do that yourself, because sometimes when we ask ChatGPT something, we then tell it, can you give me that in JSON? And here Spring does this for you. And to showcase this, even though it's a chat, I put in place small codes in the front end, and I will need to enhance my response DTO. And now I will add back what I deleted before, because that was for this demo. So now I want my chat response to contain the response, but I also want, in case the question matches any employee, I would like it to tell me which employee it matched so that I can highlight it in my tool. So that the user, for use in this case, it's nicer for the user, because if it matches an employee, it will just highlight the employee and it gives a nice feedback. So let's try it out and hope it still works. So I will just ask it the same question. What does John Doe do? And now, as you see, I don't know because it's bright. As you see, it again found out who John is, answered correctly, so we still got an answer. But it also returns the matching employees, so that I can then reuse that JSON and then in the code do what I like with it. In this case, it's front end, but you can use that in the back end. So that's that. And yeah, once again, classic Spring. It's basically one small change, and it works out of the box. So let's search and output. Okay, so that's that. Now, let's say we want to make our bot more natural, even more natural than it already starts to be. Let's say we would like, because as of now, each question I asked the bot, it's one question, one answer, and then that's it. So if I follow up on my question, it won't know how to reply to me. It will have forgotten the previous answer. So if now I ask let's say, what does Sarah do, for example? Let's switch it up a bit. Okay, Sarah Johnson works as a UI. If I ask it, does she speak Spanish? Okay. In theory, it will reply to me, okay, who is she? Who do you mean? Or if it doesn't, it will just answer anything, okay? So it didn't really answer my question. It answered a generic question on it didn't really get my. Let's try something else. Okay, what does? I'll do another example that showcases this better, because the thing is, it replied because it has in the data that it knows about the employees, all of the employees that speak Spanish, but it didn't link my my question to the previous one. So it didn't know anymore that I was just talking about Sarah and not about all the employees. So does John do? Okay, let's try something else to better showcase this, because okay, how many years of experience does he have? Okay, I think this might work, might be less ambiguous for the bot. Okay, please specify which employee you are referring to. Okay, it's a less general question, so it really doesn't know what to say. Okay, so how can we change this? Because it would be nice for our HR team to just work in the flow and not have to repeat, to keep repeating itself or repeating the names of the employees it's talking about. So we can do this by adding memory. Okay, how do we add memory? You have, well, here we'll add short-term memory, so what's called conversational memory. How do we do that? Well, we can start by changing our chat configuration that we did before, and now we'll add windowed message window chat memory. Okay, and this, to complete this dot builder, and then you can even build. Yeah. So build, and the thing is, now you need to you can. So here we declared the memory, and now we need to pass this memory to our chat client. Okay, how do we do that? We do that by declaring default advisors. Advisors basically are like interceptors in that you, I think you know, in network calls. Sometimes you want to intercept a request to add something to it to then continue. And that's basically what advisors are in this context. And so I will add it new memory. 1 second. This one I always. Okay, so you add an advisor that you built and you pass it the memory. One nice thing is that when you declare your memory, you can also tell it how much it should memorize. So you can tell it, okay, remember the last 10 messages, for example. By default, it remembers 20, I think. Yeah, by default, it remembers 20, but you can change that. Also, this one is running in memory. Well, in memory on the RAM, and but you can also persist it. You could persist the memory so that if you restart your system, even the short-time memory is not lost. Okay, so now let's try this again. And just one detail: notice how up until now, all we added was a single dependency. So it's really easy to do this kind of stuff now with Spring AI. So let's try again. Okay. What does John do? John Doe do. So works as a senior architect again. So how much experience does he have? And now, okay, I misspelled it, but it should still work. Okay, he has 14 years of experience. As we can see, it's correct. So it's correctly remembered, or it's knew that I was talking about Joe because I asked it something about Joe just before. Okay, that's it for memory. So now. Okay, so now we'll go over to a slightly more, well, it's not really that complex, but it's a bigger topic. So let's go over to RAG. I think you have heard about RAG today already a few times. So basically, RAG is a way of augmenting the limited knowledge that the LLM has, because as I said before, it was trained at some point and it doesn't know anything about that afterwards. And more importantly, it doesn't know anything about your private data. So how could we now add to it? And now I'm talking larger amounts of data, not just add something into the prompts, because you might, for example, want to query your documents. You might have policies, now I'm talking about in an HR context, but you might have policies, internal policies that are in documents, and you might just want to feed those documents to your RAG system and just then be able to ask your chatbot about it. Okay, so for that, I will just quickly jump back to the presentation because I want to just show a diagram very quickly. Okay, so it's this one. Okay, so how does RAG work? So very briefly. In RAG, what you do is you, for example, here it's documents, but you can do that with large amounts of data. It doesn't really matter because you'll see how we process this data before then be able to query it. So what you do is basically you take your data, documents, whatever, you split it, you load it, well, you transform it into vectors via embedding. It's a process called embedding. Then you basically transform the data into vector graphs, which you then split in chunks and then you store in a vector store. And why is that important? Because the vector store allows you to do what's called similarity search. So similarity search is very different from a classic, let's say, SQL query, because in an SQL query, for example, you would need to be very specific with your data and you search by value. You don't really, you might give it some regex, but you don't really search by meaning. Here you can search by meaning because it will return to you data that is more, from a meaning point of view, is nearer to your question. So that's the results you will get first. And those results will have weights. So you will then be able to filter out. You can tell it, for example, okay, we want to just keep the results that match at least 70% or 80% of my question, or maybe higher. It depends really on the criticality of what you are putting in place. So then you take this data and then you can add just the matching results to the context, and then that gets passed to your LLM. Okay, so you could do this all by hand, but again, I'll show you how Spring makes this quite easy to do. So I will switch back to the code. And for that, I have prepared, because it's a bit more code, so I will go through the code because I fear of not having enough time. This should be it. Okay. So I have prepared, as you saw from the small tool, I had prepared beforehand a small upload component. which will allow us to upload documents, okay? And to showcase how we really will just augment code that already exists. So again, we don't need to rewrite code that exists. Let's say that we already had a service, okay, a document ingestion service, which would just take the documents and store them into a DB. So here I don't do crazy stuff. It's a multi-part file coming from the front end. I check the checksum to see if it's not already in the database. And then I move it and okay, that's for later. This is actually what we're going to add. So I move it and then I store it in the repository. Okay, nothing fancy up until here. So how can we now use those documents in this AI augmented fashion? So I can first also show you that for now it doesn't know about your documents. So I'll start with that. So here, returning to our small demo, if I ask it, what is the seniority policy? Okay. If it answers, it's because I didn't clean up my vector store before the demo, so I need to clean it up and then redo the demo. So I'm sorry I can't help you with that because it doesn't know. Now we'll add, how can we ingest that data? So Spring makes it again very easily. So I've done a separate service for that matter, which is called embedding service. And here, basically, what we'll do is we will inject a vector store. Okay, I will show you the dependencies that you need for that, actually, because that's really the first time that we need to add new dependencies. So what are those dependencies? Well, we were already running on a PostgreSQL. So now what I need to add is the vector store, the PG vector plugin. Spring AI, okay, and because that's separate from the base Postgres. And actually, for similarity search, that's it. So if you are really only working with data, with text data, that would be enough. This and this would be enough. This is for later. But actually, this would be enough to perform similarity search. I added a few more stuff because I'm working with documents, and Spring put in place readers that read the document already in the correct format that we then chunk and store in the vector database. But this is really optional if you are working with documents as I'm now. You wouldn't need it if it's just text documents, you also don't need it because you just read the text from the files and then you put it in the vector store. And this I'll explain later what is this. So the embedding service, what does it do? So we pass it the file that we received. Okay. It calls the read document method. That read document method, what does it do? So basically, it just checks the extension to, okay, there are other ways to do this, but it's not really the scope of this. And if it's a text, as you see, I don't really need a fancy reader. It's just files read string, okay? If it's PDF, I use the PDF page document reader. And if it's anything else, I use the Tika document reader because this one supports more formats, more document formats, okay? And this, all three return a list of documents. But it's not any kind of document. It's already the correct Spring AI document format. So we also don't need to do that ourselves. We just use the tools that Spring provides us. Okay, but here it's not yet doing much. So let's go back to the code to our existing code base, which we already had before. What do we need to do here? Well, basically, all we need to do is we inject our embedding service that we created for this purpose. I could also have put the code in this class, but just for cleanliness reasons, I put it in a separate service. So you inject it, and then you basically just use the method that we okay. And something else I forgot to show you. So here we read the documents in the embed document. We read the documents, and then when we receive, well, we get the documents back, and then we'll split it into chunks. Yes. Okay. Yes, I'm almost done. And so the documents that we receive, we split them into chunks. And those chunks, because it's important for the performance of the similarity search that it's not too many, the chunks are not too big. So we'll basically split the documents into multiple chunks, and then we'll just add metadata to it and add them to the vector store. That's it. And in our existing code base, we just call this method. And now, if we want to use this, well, we could do a similarity search by hand. I would show you, but I don't have time anymore. So I'm not going to do that, but I will show you how Spring made that easier for us. So basically here, as you can see, in our previous chat client, we just add a new advisor, which is a question-answer advisor, which is from Spring. And you pass it to vector store, and it will know, okay, I need to first search in the vector store, and then I need to add this to the context. So just a small demo very quickly, and then we're done. I'll just rerun this because otherwise it won't work. Okay, I prepared a very simple document. Okay, it's just some internal guidelines for employees. Upload it. Okay, it was correctly uploaded, and now I'll ask it the same as before. What is the T policy? And hopefully it will answer correctly. Okay, so employees are entitled to an extra day of paid annual leave per year for 5 years of seniority, and this is correct. I can show you the document if you like. So that's here. So that's it. There are other things in AI, as you saw today, but yeah, we don't have time to show them all, but Spring really has wide support for tools. So that's it.